So the Sishyd method of assigning elevations is before MicroStation got digital terrain models. And we can place a file called elevation.xyz in the project folder. And if the file is there, we will look at the coordinates for interpolation. And that can be done later in combination with a selection dialog box. So it's the following method. You open the selection dialog box. I think we collect all the elements, select all network objects, and then you find some actions. And one is set node with elevation 0 to elevation of closest node. Let's have a look and have one node open while we are performing the operation. And from the coordinates you saw, let me go to the project folder. Here I put the file elevation xyz. I can pass on to you so that you can try on your own. It contains the xyz coordinates. What I did, I just clicked here with the left-right key. You get a feedback, this tentative point here in the status bar. It gives you the the x coordinate and the y coordinate. And so I clicked in a few spots here to find out, to figure out some xy coordinates and give it an elevation. And this file is now present in the project folder. So when I run this action, it should start with the with assigning the elevations. Let me go to this node. Currently supply and return are at 0 elevation. It looks up, and this is the closest node is on an elevation of 8 meters. Now I corrected the node elevations, but node elevations are one part of the story. The inflection points here of pipes are also at an elevation, and we use this elevation not to compute any hydraulics, but when we determine the length of a pipe. It goes from start node to the bend, and if there is a difference in elevation, we take that for the length computation into account. So you want always to interpolate these z coordinates of pipes properly. Okay, there is another action. Linear interpolation of inflection point elevations. When I click this, we should find that this point gets recomputed. Let's have a look at the start node. It's at 25 meters. The end node is at 30 meters. So this should be more 26 than 27.5. It's much closer to this point. Oh, it depends how close it is to the point that makes this these elevations. But so I go here and I interpolate, and let me go to the list so that you can see it's updating. So it's 26.45. And since we now added elevations, the length of the pipe is no longer the pipe on the flat ground. There is an elevation profile, so the length should be adopted also. We have here one visit that was before there was the selection dialog box, validate pipe length. When you run this one, it will report all pipes which differ in lengths between length in graphic minus length in the pipe dialog box. If the difference is bigger than 0.5 meters, the pipe will be reported. And only pipes above the threshold value, and it uses the threshold value. So it just compiles a report, and these would be the differences: length old, length new, and the difference in length. So it's 1.3 meters. It is not too severe in this case, but it can be make quite a difference if you deal with other elevations. So if your elevation starts at 300 meters, and this is the level, and you go down to 0 for an inflection point, yeah, it immediately adds 300 meters to the length. So you have to correct this. There is another action, so it's just a mouse click. You can update pipe length using graphic data. It is now important to note that the operations you select here, they only apply to the elements you have here selected in the box. AJ, in your case, you said there were a few pipes at the supply station you don't want to have any length, so you manually set them to 0.1 meters. You can exclude the pipes from the selection, and then those ones would not be touched if you want to recompute length. In my case, I want to recompute all length, so I'm happy with the selection. So I click Update Pipe Length using graphical data. And let's see here, so that this should slightly change, 66.4. Yeah, 0.2 meters. That's not too significant. Okay, that's where this point is important. Maybe this is also a good point in time to show how it works together with microstation fence operations. So if you want to restrict the operation to elements in a certain area, before I do that, let me undo the last step so that we have differences in length again. So I'm back to 66.4 meters, and this is the pipe here at the end, K20 to K22. So this one here at the end. Let me now define a fence. A fence is a block inside to only include pipes in this area, and the intersection is included. Now I can use a union, a difference, or an intersection. So whatever is in the list, when I intersect it with a fence, only the elements in common remain in the selection. So let me click this, and before I click, let's have a look. The selection has 82 objects at all. I built the intersection, and now I'm down to 70 elements. And I will apply the linear interpolation of inflection point elevation. No, sorry, the update pipe length operation only to elements in this region. So now there are still a few pipes here that are incorrect. I use a threshold, but I go down to 0.1 meters. The difference here was about 0.2. So we should find KO20 to KO22, this pipe here, which was outside the region we were correcting. K20, K22. The difference is, yes, the approximate 0.2 meters. So it's correct that this one gets reported. The other one is the one here upwards. This one intersects, so it was included. So it's just these two pipes I did not correct. And if I select everything or all elements, I can adopt the changes, or here's with the wizard the same option. Can just update. So this is now on 66.6 also. But the selection dialog gives you much more control in combination with the fence. And the fence may not be just a block. It can be a shape, a circle. So you can make these weird things like these shapes and use the full power of MicroStation to build these forms. So, and such a shape can be stored in the DGN that you can get back to it. For example, if you want to define a shape around the supply stations where the pipes are 0.1 meters in your example, AJ. And then it's easy to select the shape, exclude it, so the minus, select difference, and then the operation can be performed on all other elements of the network. When you add new elements to the graphics, you probably want to do the operation again, but maybe then just include elements from that range. How would you do that? I clear the selection set. And if I, for example, create here a new node and a new pipe, the node got an elevation. So the system just understood it got the it has inherited the 30. But now I would define a fence which includes only these elements, and then I would be able to do the same operations again. Oh, sorry, there is no. I want to select the union. So if the selection set is blank, union will add all elements that are inside and overlapping this fence. And in the material, we state this title is not 100% correct. Set nodes with elevation 0 to elevation of closest node. When there is the XYZ file in place, it always takes the information from there, regardless of the node elevation. Before we had the file in place, this operation was used to use the elevation from the closest node at a known elevation. And with the extension, we were able to use the ones in the file. Ultimately, nowadays, we would use the MicroStation digital terrain model that is meanwhile available. Okay, I think that's it for demonstrating how to deal with elevation data. And of course, when you extend the area, you are free to add any number of nodes to this list. We will just get through the list and compute the closest and use the coordinate with the closest distance and take the elevation from there. So for the one node with the 8-meter elevation, it was most likely closest to the minus 624.7 coordinate.